Alright, so the very last section we're looking at complex numbers. Before I tell you what a complex number is, let's look first at what an imaginary number is. Alright, the most basic imaginary number is defined as the letter I, and it is the square root of -1. Any other imaginary number comes from this right here, this I that we have defined. So, quick example of where that's going to come from. Let's say I have the square root of -4. The square root of 4 is 2, so the square root of -4 is just 2i. That -1 comes out as I. We can simplify those pretty easily. Now, the imaginary numbers, this I, it's a cyclic number. What I mean by that is it ends up repeating its cycle after 4 different times. So we define I to be the square root of -1. If I square I squared, what do you think that's going to give me? What is it going to give me? -1, right? If I square a square root, the square root just cancels out with the square, and I end up with -1. So what then would I cubed be? What is it? Just throwing things out there. Very good, Anthony. It's negative square root of -1, right? I cubed means I'm multiplying these two together. So it's -1 times the square root of -1, which gives me -I. And then I to the 4th power would then give me what? What would it be? It's 1. I to the 4th power is just 1, right? Because I'm squaring I squared, so I to the 4th just gives me 1. Now I'm going to do one more. What do you think I to the 5th power would be? Square root of -1. Once I get through the first 4, it just repeats. I to the 5th is I, so I to the 6th is -1. I to the 7th is -I, so on and so forth. So every 4, it's going to repeat. So I don't want to have to do that over and over and over again. So let's say I want to know, what is I to the 37th power? Very simple way, since we know it repeats every 4, I'll take whatever power I have, divide it by 4, and take the remainder. 4 goes into 37 9 times, with a remainder of 1. So I to the 37th power is equivalent to I to the 1st power, which is just I. So every single time, whatever your power may be, divide it by 4 and take the remainder, and that's going to be what it's equivalent to. So let's do one more. I to the 99th power. Somebody tell me, what is I to the 99th power going to be equivalent to? -1, square root of -1, sure. 99 divided by 4 is 24 with a remainder of 3. 24 remainder of 3? Yeah. 24 with a remainder of 3. So I to the 99th power is the same thing as I to the 3rd, which we said simplifies to -I. So I to the 99th power is -I. Alright? So that's how we simplify, or how we would find powers of the imaginary number. So there are imaginary numbers, and there are numbers that we're used to dealing with, real numbers. So a complex number is the two combined. So a complex number, standard form of a complex number is a plus bi. So I have a real number and I have an imaginary number. A, the first part, we call the real part. This should be just a plain old real number, and it goes first. And the second part we call the imaginary part. Oh, I said real number. How about real part? And the second part is the imaginary part. So these two together make up a complex number. So a complex number is a real number and an imaginary number combined together. So an example of a complex number would be something like 3 minus 7i. Or 3 plus negative 7i. Same thing, but 3 minus 7i. And so every single number, no matter if it's real or imaginary, can be written in complex form. So let's write some numbers in standard form as a complex number. So I want to write the number 5i in standard form. If I want to write this as a complex number in standard form, what part am I missing? The real number, right? This is the imaginary part, my second part. I need the real part. What number could I put in the real part's place that isn't going to change the value of my number? 0. So 5i, written in standard form as a complex number, would just be 0 plus 5i. And likewise, if I had a real number, let's say I wanted to write 3 in standard form, what would 3 be written as a complex number in standard form? 3 plus 0i, right? It's a real number, it's missing the imaginary part. So whenever we're working with complex numbers, no matter if I only end up with an imaginary number or I only end up with a real number, we want to write our final solutions in standard form. Okay? Alright, so these are numbers, and with numbers we can do different types of operations, just like we would with real numbers. So let's look at operations with complex numbers. Operations with complex numbers. So the first two operations we'll look at is addition and subtraction. Now, to add and subtract complex numbers, it's essentially just combining like terms. So let's do an addition one first. Let's say I want to add 3 minus 7i plus negative 6 plus 4i. I want to add these two complex numbers together. So again, it just comes down to combining like terms. I'm going to add my real numbers together, and then I'll add my imaginary numbers together and make sure that I write it back in standard form. So my real numbers are 3 and negative 6. So 3 plus negative 6 gives me negative 3. There's my real part. Now the imaginary part, negative 7i plus positive 4i, should give me negative 3i. I have my real part, I have my imaginary part, so this is in standard form, and there's my final answer. So it's just combining like terms. Okay. Subtraction works exactly the same way. We just have to, again, be careful with that minus sign in the middle because it will change signs. So let's say I have 8 minus 12i minus 11 minus 15i. So I want to subtract these two complex numbers, 8 minus 12i minus 11 minus 15i. It's still just combining like terms, but I have to be careful of that minus sign in the middle. So my real parts, my real numbers, I have 8 and 11. So 8 minus 11, totally coincidental that that came out to be negative 3 again. It won't always be. But 8 minus 11 is a negative 3. And then my imaginary parts, I have a whole bunch of minus signs, so keep them straight. Negative 12i minus negative 15i. These two subtraction or negative symbols combine together to make a positive. Oh my god, how did that happen? So negative 12i plus 15i gives me positive 3i. And I'm going to do one more just to show you it's not always going to be 3's. It's not. Yeah, I gotta make sure it doesn't come out to be 3's. There we go. Alright, so let's do one more. So this one's subtraction, so be careful of your signs. And again, I'm just combining real number, imaginary number, imaginary number. So 7 minus 18 gives me negative 11. There's my real part. And 13i, positive 13i, minus negative 5i. The minus and the negative will combine and become a positive. So I have 13i plus 5i gives me positive 18i. So they won't always be 3's. Totally coincidental. Alright, questions about addition and subtraction? Alright. Now, multiplication of complex numbers. Again, it's going to be a very familiar process. I hate the word, I dislike strongly the word FOIL, but that's essentially what we're going to be doing, distributing one term to another. Let's look at multiplication. Alright, so I have 3 minus 2i times 5 plus 4i. Think about if your i's were x's. You know how to distribute things inside sets of parentheses. I'm going to multiply everything in my first set of parentheses times everything in the second set of parentheses. So starting with my 3, I'll do 3 times 5, and then 3 times 4i. So 3 times 5 gives me 15. 3 times 4i gives me positive 12i. Now I'm done with the 3, and I'll do the same with the negative 2i. So negative 2i times 5 and negative 2i times 4i. Negative 2i times 5 gives me negative 10i. Negative 2i times positive 4i will give me negative 8i squared. Now our final answer needs to be in standard form, meaning I just have a real part and a plain old imaginary part. So I need to go through and simplify. The first thing I see, I have like terms. So I have 12i minus 10i, so I'll go ahead and combine those. So I have 15. 12i minus 10i is positive 2i minus 8i squared. Now I have this nasty I squared here at the end. That's definitely not part of my standard form of a complex number, but we talked about in the beginning what I squared equals. What is I squared? It's just negative 1, right? So I can simplify this and say, okay, well that means 15 plus 2i minus 8 times negative 1. And now that becomes just a real number, 15 plus 2i plus 8. And so I can combine again like terms. 15 and 8 are both real numbers, so they are like terms. And 15 plus 8 gives me 23 plus 2i. I have my real part, I have my imaginary part. They are separate, and it's my final answer. Okay, so it's just distribution. Alright, let's do one more. Alright, so I have 1 minus 5i times 6 plus 2i. And again, I'm just going to distribute, simplify, and combine like terms. So I get 6 plus 2i minus 30i minus 10i squared. The negative 10i squared, I squared is negative 1, so negative 10i squared turns just to positive 10, a little shortcut. Now I can combine my like terms. My two real numbers give me 16. My two imaginary numbers give me negative 28i. Alright, so the final operation that we'll do is division. In order to divide two complex numbers, we first need a little extra piece of information. It's called the complex conjugate. Now, the complex conjugate is a fancy way of saying I'm going to change the sign of the imaginary part. That's all it means. Change the sign of the imaginary part. But it's nice to know the notation. So, say I have this complex number, a plus bi, and I need to take the complex conjugate of it. The notation or the symbol that I would use to tell you to do that is just simply a bar over the top. A plus bi with the bar over the top means that I want you to take the complex conjugate of it, which all that does is change the sign of the imaginary part. The real part will stay completely the same no matter what it is. The imaginary part will just flip signs. If it was positive, it's now negative. If it was negative, it's now positive. So, quick example of that. Let's say I have negative 3 minus 7i. And if I put a little bar over the top, that means I'm taking the complex conjugate of it. All that does is change the sign of the imaginary part, so that leaves me with negative 3 plus 7i. Alright, now we need this in order to divide our complex numbers. Good? Alright. So let's look at division. Alright, so let's say I want to divide 1 plus 3i by 2 minus 5i. In order to divide two complex numbers, I'm just going to multiply the numerator and the denominator by the complex conjugate of the denominator. So all that says, complex conjugate of the denominator, what's it going to be? 2 plus 5i, right? So I'm going to multiply the top by 2 plus 5i, and I'll multiply the bottom by 2 plus 5i. And we just looked at how to multiply my complex numbers. I'm just going to distribute, or FOIL, right? FOIL. It tastes bad whenever I say that. Alright, so multiply on the top. If I distribute, I end up with 2 plus 5i plus 6i plus 15i squared over, on the bottom, I get 4 plus 10i minus 10i minus 25i squared. So we simplify the top, simplify the bottom, and write it in standard form. So on the top, my 15i squared will change to what? Negative 15 or minus 15, right? I squared is just going to change that sign. And so 2 minus 15, my real numbers, combining my like terms, gives me negative 13. And 5i plus 6i gives me positive 11i. Over, what do we have on the bottom? Notice my two middle terms are the same, but the opposites, right? This should happen every single time. If you look at this, this is like the factors of the difference of squares. My middle term should cancel out. Should happen that way every time. If it doesn't, oops, we made a mistake, go back and fix it, right? But these two should cancel out. The negative 25i squared, the I squared changes the sign, just makes it positive 25. I squared goes away. So I end up with 4 plus 25, which is 29 on the bottom. Now, in order to write this in standard form, I need to separate it, break it up into two different fractions. So I'll have negative 13 over 29 as my real part. It is reduced, so I can leave it, plus 11 over 29i. 11 over 29 is reduced as well, so this is my final answer. Questions? Peach cane jelly beans? Alright, so now let's get to the fun part. Alright, so writing complex numbers in trigonometric form. Alright, so first thing to really think about, generally when we graph things, we're looking at the x and y plane, right? I have an x value and I have a y value. Well, we can graph a complex number. If we think of the y-axis as the imaginary axis and the x-axis as my real axis, then let's say I have 1 plus 3i. Take this number right here. 1 plus 3i. Then I can plot it. I have 1 for my real number, so I'll go up to 1. And 3 for my imaginary number, so I'll go up 1, 2, 3. And I get this point right here. Well, if you think back to the very beginning of the semester when we talked about angles, how angles were formed, the initial side of an angle is going to be on the positive x-axis, or in this case, the positive real axis, and the terminal side would pass through a single point. And an angle is formed. We'll call this angle theta, and we'll call, pretend I didn't draw that past that point, we'll call the length of the line from the origin to that point, we'll call it r. So I have r, and the angle formed theta. So if I want to write a complex number, a plus bi, in trigonometric form, it's going to equal this r value, the hypotenuse of this triangle, and we'll talk about that in just a second. So it is trig. Can you all see that? Yeah? Okay. So r times cosine of the angle that's formed plus I times sine of the angle that's formed. Now r, this is the hypotenuse of that triangle. How can I find r? What is it, Anthony? A squared plus b squared, right? This is just Pythagorean theorem. It's also the absolute value of a complex number. So the absolute value of a complex number, this is a little side note, absolute value of a complex number will give us that hypotenuse, r, which comes down to just the Pythagorean theorem. So it'll be a squared plus b squared, and then take the square root of it. So that's how I would find that r value, and we'll do an example in just a second. So that takes care of finding r. How am I going to find theta? What's one way I could find theta? Anybody? Work with the triangle, right? Work with the triangle. If I pop this triangle out, let's look at it kind of blown up here. I'm looking for this angle theta. I have my hypotenuse is r. The bottom is the real part of my complex number, which is a, and the side, the height, is the imaginary part. How can I find theta? What's one way I could find theta? I could use sine, right? So sine of theta would be equal to what? B over r. B over r. B over r. I agree. And what's another one? Very good. So either one of these little equations that y'all just developed, hand clap, very nice. Either one of these will work out perfectly fine. You can use either one, whichever one seems to be easier. Another form that you'll see them written in is that B is equal to r sine of theta, and A is equal to r cosine of theta. Okay? All right, so let's do an actual example. We got this? No? I'll give you a second. Now, real quick before we go into this, what quadrant was this complex number in? 1. So my angle should be between what? Between 0 and 90, right? So we'll come back to that in a second. All right, so let's do an example. All right, so let's say Alright, so I want to write 2 minus 3i in trigonometric form. So the first thing I'm going to do is I'm going to graph it to see what quadrant I'm in. So I have positive 2 on the x-axis or on the real axis and negative 3 on the imaginary axis. So I'm right here. So I'm in quadrant 4, right? So I need to find this angle theta, and I need to find that r value. It's very small. And so I'll start off and I'll find r. R is going to be the square root of 2 squared plus 3 squared, which is going to be equal to the square root of 4 plus 9, which will be the square root of 13. And so to find theta, I can either use sine or cosine. It doesn't matter. I'll use sine for this problem. So I know that B is equal to r sine of theta. You could use cosine, but I'm going to use sine. I know what B is. What is B in this case?
3.
It is what? It's negative 3, right? And we just found r to be the square root of 13. So putting this in, B is negative 3, r is the square root of 13, and sine of theta. So I get sine of theta is equal to negative 3 square root of 3 over square root of 13. Do I know this value off the unit circle? No, I don't. So how could I figure out what what theta was? Inverse, right? So using my calculator, so I'm going to have theta equals sine inverse of negative 3 over the square root of 13. So handy dandy calculator. Make sure that we are in degrees. We'll write our answer in degrees. I am in degrees. So I will do sine inverse of negative 3 divided by the square root of 13. Make sure you enter everything in, put your parentheses in appropriately. And I get negative 56.31. Now, I don't want a negative angle. I want a positive angle. I know I'm in the fourth quadrant. Subtract it from 360, right? Or, yeah, subtract it from 360. So I'm going to have 360 degrees minus 56.31 degrees. Which is going to give me 4/6. There we go. 303.69 degrees. So I have my angle theta. It is in the fourth quadrant. This does make sense, the answer that I have. And I know that r is the square root of 13. So to write my complex number, 2 minus 3i, in trigonometric form, I'll have 2 minus 3i equals r, which is the square root of 13, times cosine of 303.69 plus I sine of 303.69. My degree symbol, close my parentheses, and there we go. There is my complex number in trigonometric form. Questions about that? Yeah? No? Okay. Alrighty. Moving on. I ran out of paper. Alright, so going the opposite direction, say I have trigonometric form of a complex number and I want to rewrite it in standard form. So, trig form back to standard form. If I'm going from trig form back to standard form, all the hard work is already done for me. So let's say I have that off there. There we go. So let's say I have 4 times cosine of 120 plus I sine of 120. And I want to go from trigonometric form back to standard form. It's just a matter of figuring out what cosine of 120 is and sine of 120 is, and then multiplying it by 4. This will yield your real part, and 4 times sine of 120 will give your imaginary part. What is cosine of 120? That unit circle, that unit circle. So 120 is a value on the unit circle, so we should be able to give an exact answer. Cosine of 120 degrees negative 1/2. So I'll have 4 times negative 1/2 plus sine of 120 degrees square root of 3 over 2. So square root of 3 over 2 I. And now multiplying by 4 and simplifying gives me negative 2 plus 2I square roots of 3. And this is just a little bit of formality, notation. Whenever we're dealing with I and square roots, I generally will go in front, but behind the whole number, or the number outside of the square root. So it should go regular number, imaginary number, square root. Okay? Just so there's no confusion as to what's under the square root. But that's it. Now, what if the angle I had was not on my unit circle? What would I do? just plug it in your calculator. Okay? Just plug it in your calculator, see what you got. All right. Last thing, a little bit of operations with our trigonometric form. So multiplying Alright, so multiplying complex numbers in trigonometric form, very, very simple. I kind of crowded that in, I ran out of room. But so I want to multiply my complex numbers in trigonometric form, and then we're going to add a little bit to that. I want to write it back in standard form. So very simple. When we're multiplying complex numbers in trigonometric form, I'm simply just going to multiply the r values together. So I'll multiply 3 times 2, gives me 6. And then I'm going to add the angles together. So I'll have cosine of 25 plus 50 gives me 75, plus I sine, it'll be 75 as well. So I multiplied my two complex numbers together. And now to write it back in standard form, I just need to know what cosine of 75 is. 75 is not a pretty number on my unit circle, so I'll come over to my handy-dandy calculator and type in cosine of 75, and I'm going to multiply that times 6. This gives me my real part, so I have 1.55 or 1.6, whatever we're rounding to. And same thing with sine. I need to figure out what sine of 75 is and multiply that times my new r value. And I get plus 5.79 I. So there are my complex numbers in trigonometric form, multiplied together, and converted back to standard form. So you just simply multiply the r values together, multiply my r values together, add the angles together, and then I just figured out what cosine of 75 was times 6, gives me 1.55, and then figured out what sine of 75 was times 6, gives me 5.79, and then I. Easy peasy lemon squeezy. Questions? No? Alright. Very last thing. I know, you're so excited. Alright. Very last thing is division. 2 seconds, bear with me. Alright, so division of trigonometric, complex numbers in trig form works very similar to multiplying, except I'll divide and I'll subtract. So I want to do Alright, so in dividing my complex numbers when they're in trig form, I just divide my r values. So in this case, I would have 21 divided by 14 is 3 over 2, or 1.5, times. Now, whenever we multiplied, we added my angles together. With division, we'll subtract the angles. So I'll have cosine of 210 plus I sine of 210. And I want to write my final answer in standard form. So I'll have 3/2 times cosine of 210 degrees. 210 is a pretty number on the unit circle. What is cosine of 210 degrees? Negative square root of 3 over 2, I agree. Plus I times what? Sine of 210? Negative 1/2. And so multiplying that, simplifying it, my real part, I'll have negative 3 square root of 3 over 4. And my imaginary part, I'm going to have negative 3 over 4i. So if my angle turns out to be something on the unit circle, I want to have an exact value. That's the point of the unit circle. If it's not on the unit circle, then an approximated value is sufficient.